20,000 Leagues Under the Sea, Chapter 12, All by Electricity. Monsieur, said Captain Nemo, pointing to the instruments hanging on the walls of his room, these are the devices needed to navigate the Nautilus. Here, as in the lounge, I have them always in sight, and they tell me my exact position and direction in the middle of the ocean. Some of them you already know, such as the thermometer, which gives the inside temperature of the Nautilus, the barometer, which indicates atmospheric pressure and predicts changes of weather, the hygrometer, which shows the dryness of the air, the storm glass, whose contents decompose and announce the arrival of storms, the compass, which gives me my course, the sextant, which, by determining the height of the sun, gives me my latitude, my chronometers, which permit me to find out my longitude, and lastly my telescopes, one for the day and the other for nighttime use, with which I examine every corner of the horizon when the Nautilus is on the surface. These are the usual nautical instruments, I answered, and I know how they're used, but I see others which undoubtedly answer the Nautilus's special needs. Isn't that dial with a moving needle a pressure gauge? Yes, it's a pressure gauge. It's in contact with the water outside, and by giving me its pressure, tells me at what depth I'm traveling. And are these some new kind of sounding lines? They're thermometrical sounding lines to give me the temperature of the various layers of water. And what are these other instruments which are completely unfamiliar to me? Before going any further, Professor, I must explain a few things, said Captain Nemo, so please listen. After a few moments of silence, he said, there is one source of power which is obedient and rapid, easy and pliable, and which reigns supreme on board my ship. It does everything. It gives me light, heat, and is the soul of all my machinery. This source is electricity. Electricity, I cried, somewhat surprised. Yes, monsieur. But, Captain, the great speed with which your ship can move would seem to have little to do with electric power. Until now, its dynamic force has remained very limited and able to produce no more than a few very small amounts of energy. Professor, answered Captain Nemo, my electricity is not the usual kind, but I hope you will permit me not to go into it further. I won't insist on the matter, monsieur, and I will be quite satisfied to be astounded at the results you have obtained with it. There is one question I would like to ask, however, but you need not answer it if it's indiscreet. The materials you use to produce this marvelous source of power must get quickly used up. How, for instance, do you replace your zinc without going on shore? I will first answer your questions in a moment, Captain Nemo replied. First, however, I would like to mention that in the ocean depths there exist mines of zinc, iron, silver, and gold, which would be quite easy to exploit, but I have used none of these earthly metals. I wanted to take only from the sea itself the means of producing my electricity. The sea? Yes, Professor, and it was not difficult. In fact, by establishing a circuit between two wires at different depths, I could have obtained electricity through the resultant differences in temperature, but I preferred to use a more practical system. What was that? You know the composition of seawater, don't you? Every 1,000 grams contains 96.5% of water and about 2 2/3% of sodium chloride, and then small quantities of magnesium chloride, potassium, magnesium bromide, magnesium sulfate, and carbonate of lime. So you see that it contains a relatively large proportion of sodium chloride, and it is this sodium that I extract from seawater and use as a basic element. Sodium? Yes, monsieur. When mixed with mercury, it forms an amalgam which can replace zinc in batteries. The mercury never gets used up. Only the sodium is consumed, and the sea itself furnishes me with a steady supply of it. And besides, let me tell you that sodium batteries are the most powerful of all, their electromotive force being double that of zinc batteries. I can well understand, Captain, the excellence of such sodium. The sea contains it. Fine. But you still have to manufacture it, extract it. How do you manage that? Your batteries could obviously be used in this process, but if I'm not mistaken, the amount of sodium used up in this process would be greater than the amount extracted. You would therefore be using it up faster than you could produce it. No, Professor, I don't extract it by means of batteries. I merely heat it by means of coal. Coal, I said. Yes, but gotten from the sea, replied Captain Nemo. Can you dig coal from underwater mines? Later, you will see me do it. I only ask you to be a bit patient. You'll have plenty of time for patience. But keep this in mind. I get everything from the ocean. It produces my electricity, and electricity gives the Nautilus its heat, light, and movement. In short, its life. But not the air you breathe? Oh, I could make the air I need, but I could see no use in it since I can surface any time I want. But if electricity doesn't supply me with air, it at least operates the powerful pumps which stored in special tanks, thus allowing me to remain in the ocean depths as long as I want. Captain, I said, I can only admire what you've done. You've obviously discovered something which other men will one day find out, the true dynamic force of electricity. I'm not so sure they will find it, Captain Nemo answered coldly, but in any case, you already know one use I've made of this precious source of energy. It gives us light that is more uniform and continuous than that of the sun. Now look at this clock. It's electric and works with an accuracy that surpasses the finest chronometers. I've had it divided into 24 hours like Italian clocks because for me, there exists no night or day, no sun or moon, but only this artificial light that I bring with me to the ocean depths. As you can see, it's now 10 o'clock. Precisely. Another use of electricity. This dial in front of us indicates the speed of the Nautilus. It is connected by an electric wire to the patent log, and its needle tells me the ship's actual speed. Right now, in fact, we're cruising at 15 knots. Marvelous, I replied. How right you were, Captain, to use such a source of power. It can replace wind, water, and steam. We're not through, Monsieur Aronnax, said Captain Nemo, getting up. If you'll be kind enough to follow me, we'll visit the after part of the Nautilus. I was by now familiar with the entire forward part of the submarine, and here's an exact description of how it was divided up, starting amidships and going forward to the spur on its prow. First, there was the dining room, 16.5 feet long and separated from the library by a watertight bulkhead. Then the library, also 16.5 feet long. Afterward came the big lounge, 33 feet long, separated from the captain's room, which was 16.5 feet long. Then my cabin, 8 feet long. And lastly, an air reservoir, which was 24.5 feet long and extended up to the bow. That made a total of 115 feet. The watertight bulkheads had doors that could be hermetically closed by means of a kind of rubber gasket around the edge, and these doors made the Nautilus safe, even if it should spring a leak. I followed Captain Nemo down the gangway to the center of the ship. There I saw a kind of well between two watertight bulkheads. An iron ladder, leaned against the wall, led to its upper end. I asked the captain where it led. To the dinghy, he replied. What, you have a dinghy on board? I exclaimed in surprise. Certainly, and it's a splendid little boat, light and unsinkable. We use it when we want to go fishing or out for a stroll. But that means you have to surface in order to use it. Not at all. This dinghy is lashed to the upper part of the Nautilus's hull and set in a hollow place especially designed for it. It's completely covered by its own deck, and thus absolutely watertight. It's held down with strong bolts. This ladder leads to a hatch in the Nautilus's hull, which corresponds to a similar hatch in the side of the dinghy. This allows me to go straight up into the dinghy. The crew closes one hatch, the one on the Nautilus, and I close the other by means of press screws. I then undo the bolts, and the boat shoots up to the surface. Once there, I open the hatch cover, which till now has been kept tightly closed, set up the mast and sails, or take out my oars, and I'm off. But then, how do you come back on board? I don't come back, Monsieur Aronnax. The Nautilus comes to me. At a command from you, I suppose? Yes, at a command from me. I remain attached to it by an electric wire. I send them a message, and that's that. Right, I said, intoxicated with all these wonders. Nothing could be simpler. After passing the stairs which led to the platform, I saw a cabin about 6.5 feet long in which Conseil and Ned Land were busy devouring their lunch. From there, a door opened onto a 10-foot kitchen situated between the ship's vast storerooms. There, all the cooking was done by electricity, which for this purpose was even more powerful and obedient than gas. Platinum sponges connected to electric wires and placed beneath the tops of stoves gave off an even heat over a large area. Electricity was also used to heat a still, which, by means of evaporation, supplied excellent drinking water. Next to the kitchen, there was a well-laid-out bathroom, complete with hot and cold running water. Beyond the kitchen was the crew's quarters, about 16.5 feet long, but the door was closed, and I could not see how it was furnished, and hence perhaps get an idea of the number of men needed to operate the Nautilus. Then came a fourth watertight bulkhead separating this room from the engine room. A door opened, and I found myself in the compartment where Captain Nemo, undoubtedly a first-class engineer himself, had placed the machinery which drove his vessel. This well-lit room was at least 65 feet long. It was divided into two sections. The first contained the apparatus for producing electricity, and the second, the mechanism for transmitting this power to the propeller. I was first of all surprised by a rather peculiar odor which filled the compartment. Captain Nemo guessed my thoughts. "It comes from the gas given off in using sodium," he said, "but it produces nothing more than a slight discomfort. And besides, every morning we purify the ship by ventilating it with fresh air." In the meanwhile, I was examining the Nautilus's machinery with the greatest curiosity. "As you can see," said Captain Nemo, "I use Bunsen cells instead of those developed by Ruhmkorff, which would have been useless. The Bunsen cells are few but large and powerful, which in my experience is an advantage. The electricity passes back through big electromagnets, actuating a set of rods and gears, which in turn transmit the power to the propeller shaft. The propeller is 20 feet in diameter, has a pitch of 25 feet, and can do up to 120 revolutions per minute." "What speed does that give you?" 50 knots. There was a mystery behind all this, but I did not want to ask too many questions. How could electricity be made to produce such power? Where did this almost limitless force originate? Was it in some high tension developed by a new kind of coil? Was there something about its transmission that an unknown system of levers could increase infinitely? There was no way of knowing. "Captain Nemo," I said, "I am fully aware of the results, and I don't expect any explanations. I saw the Nautilus maneuver around the Abraham Lincoln, and so I'm well acquainted with its speed, but that isn't enough. You have to be able to see where you're going. You have to be able to steer the ship to the right or to the left and up and down. How do you reach the great ocean depths where the water pressure has to be counted in the hundreds of atmospheres? How do you come back to the surface? And lastly, how do you stay at a desired depth? I hope I'm not being too inquisitive." "Not at all, Professor," replied the captain after a moment's hesitation. "In view of the fact that you're destined never to leave this submarine, come to the lounge. That is our real workroom, and there I'll tell you everything you want to know about the Nautilus."